Hello students, in this video I will show you how to calculate binomial probabilities using Desmos graphing calculator. This is from the section The Binomial Distribution from the chapter Discrete Probability Distributions. If you still need help understanding when you include or not include a particular outcome and you need help distinguishing between exclusive and inclusive intervals, please go back to part 2 of these videos, which is where I show you the formula to compute binomial probabilities, and I also go over the difference between PDF and CDF functions and how to apply them depending on what you're asked to do or what information you're provided with. I'm going to be using the same example from the first video where I introduced the binomial distributions of a random variable, of discrete random variables, The Pew Research recently reported that approximately 30% of the internet users in the United States use the website Pinterest. Suppose a simple random sample of 15 internet users is taken. Let's take the information that we're provided with and organize it. We have a simple random sample of 15 internet users. That will be our number of trials. We're going to denote our success and failure events as finding a Pinterest user for success and finding a non-user of Pinterest as a failure. Our probability of finding a Pinterest user is 0.30, since approximately 30% of the United States internet users actually use Pinterest. Our probability of failure will be the remainder of 1 minus the probability of success, which is 0.70 in this case, and we had already checked if this was a binomial distribution because we also have independent events. We already calculated this probability using the formula, or what I had labeled as by hand, but let me show you how to calculate this probability using Desmos calculator. We want to use the binomial probability distribution to find the probability that exactly 4 of the sampled people used Pinterest. I'm going to go to Desmos, and first I need to set my binomial distribution. I'm going to use the graphing calculator. The scientific calculator does not have this feature, so make sure that you are in the graphing suite of Desmos. Mine's in Spanish. Your calculator should have the same buttons, just in a different language. You're going to click here on the keyboard menu that you're having, and you're going to go to functions. You're going to scroll down until you see distributions. We are going to be having a binomial distribution. If you notice, there's going to be like a flag over here. You're going to have to label first with an uppercase letter your discrete random variable. We usually use capital letters. I don't know if it makes a difference, but we're going to label this discrete random variable X, and we're going to set the binomial distribution. It gives you instructions over here. Again, mine's in Spanish, but you have to first put the number of trials, or your N value, and then you're going to put the probability of success. You're going to put N and P. My number of trials for this problem or this question is 15, and my probability of success is 0.30. You can put it as 0.30 or 0.30. You're going to be seeing here the distribution. This is how your graph will look for this discrete distribution. You don't need to see the graph, but just in case you're wondering, this is what this represents. Now, I'm looking for the probability of exactly 4 users. Exactly 4 means PDF. We're using the probability density function. Again, if you need help understanding what I mean, please go back to the second video. In notation form, I want the probability of my outcome being exactly 4. Because it's exactly 4, it will be PDF. And, where is it? You're going to go back to the menu, functions, PDF right here under binomial distribution to the left, PDF. But notice how again it gives you a flag. Depending on what letter you use or what name you gave to your discrete random variable, you're going to start that command PDF with that random variable and then a point. I want the probability that x is equal to 4. So the probability of finding exactly 4 is 21.86. 21.86%. Let's go now over a CDF example, a cumulative distribution function. We want to use the binomial probability distribution to find the probability that fewer than 3 of the people use Pinterest. You need to read the question. Fewer than 3. Fewer than 3 means we're not including 3. We want 0, 1, or 2, but not 3. If you choose to use the command CDF and you put the 3, it will give you the probability of up to 3. If you put CDF 3, this will be the probability of up to 3. We don't want 3, we want fewer than 3. And since I want to do my cut over here, instead of putting CDF 3, I'm going to have to put CDF 2. Oh, sorry. I just want to move the arrow. I want CDF 2. Again, I have to put the name of my discrete random variable first. And now I'm going to put the command CDF. You can type it. You can type CDF. Or you can click on functions again. Go back to distributions. CDF. And I want up to 2 values. This is the probability of 0 or 1 or 2 people being users of Pinterest. 12.68%. In notation form, this is the probability of x is fewer than 3, but because our command CDF gives us up to 2, up to whatever value we put, we change this probability to be the probability of x is smaller than or equal to 2. They're the exact same thing. They're both equal to each other. It's just that in your calculator, you can only compute using the less than or equal to, not less than. 12.68, I forgot the number. 12.68%. Now let's use the binomial probability distribution to find the probability that more than one person uses Pinterest. I want the probability that more than one person, x is greater than 1. More than 1 does not include that 1. If we have the probability of 0 users, 1 user, 2 Pinterest users, 3 Pinterest users, 4, all the way to all of them being Pinterest users, I want more than 1, that is 2 or 3 or 4 or 5, including the 2. My CDF command gives me my probability of fewer than including that value. So instead of calculating this portion, I want to calculate that portion, but I can't. My CDF command gives me this area up to that value. Because I'm looking for 2 or greater than, like this, I'm going to use my command for computing the probability of 0 and 1, or in other words, up to 1. I'm going to compute the probability of x is less than or equal to 1. And then to find the remaining portion, to find the rest, I'm going to subtract that probability from 1. 1 minus the probability of x is smaller than or equal to 1. We're doing this adjustment because my calculator can only find me the probability of a value smaller than or equal to an outcome. And I'm subtracting it from 1 because my total sum of probabilities adds up to 1. All right, so on the Desmos calculator, you can put the whole thing together. You can put 1 minus, my discrete random variable was x. I'm going to type it this time. CDF, parentheses, I want up to 1. There you go. 96.47%. 96.47%. You could have done it by parts. You could have find first the probability of at most 1, or the probability of x is less than or equal to 1, and then subtract it from 1. But because we have the Desmos calculator and you can do it all straight in one shot, feel free to do it all together. Next scenario. We want to find the probability that the number of people who use Pinterest is between 1 and 4 inclusive. This inclusive word means that I'm including the 1, including the 4. In notation form, that's the probability of x being between 1 and 4, and the inclusive part adds the or equal to our inequality symbol. Again, if we have our possible outcome 0, 1, 2, 3, 4, 5, all the way to 50, all 15 people being users of Pinterest. Let me put the 5 too, because it's a value that we're going to need. I want the probability of having 1 or 2 or 3 or 4 users. What I can do is compute the probability up to 4 using that CDF command, and then take away the probability of 0. In other words, find CDF of 4 and then subtract the probability of exactly 0. What's the command for exactly a value? PDF of 0. Like this. That's how I will find the probability of this one. In other words, what I'm doing is finding the probability. Let me put it here. Because we're doing it by parts, I'm finding the probability of x is smaller than or equal to 4. And then I'm subtracting the probability of x is equal to 0. I go to Desmos. My discrete random variable that I labeled was x. I had to do it because this is my information that I gave Desmos to use. CDF of 4, because I want all the way up to 4, but I'm going to subtract the PDF of 0. This is your probability. Again, you can do it by parts, but because Desmos allows me to do it all straight, all in one command, I'm going to use a single command. My probability of finding a person finding between 1 and 4 users of Pinterest, including 1 or including 4, is 51.07%. Oh, I forgot the percent. Again, find the probability that exactly 5 of the sample people use Pinterest. Exactly 5. That is just 5. In notation form, that's the probability of x is equal to 5. If I go to Desmos, that will be a PDF problem. X, that's the name that I gave to my discrete random variable. Exactly 5. 20.61%. Now, to find the probability that fewer than 4 of the people use Pinterest, that's the probability of x is smaller than 4. But remember, I can only use the CDF command, and that one gives me up to that value. So instead of going to find fewer than 4, I have to go one down and find up to that value. Let me show you again. I'm looking for the probability of 0 or 1 or 2 or 3, but not 4, because fewer than 4 is 3 or less or fewer. So I'm going to use the command CDF3. .69%. It requires practice for you to be able to set up your notation and understand what you're asking the calculator to do. But once you learn the difference between the commands and learn how to use the notation, the X for the name of the variable, the random variable, and how to look for the commands, it will be very quick to solve this question, since the calculator is doing all of the work and you don't have to manually compute all of those probabilities. Find the probability that the number of sampled people who use Pinterest is between 6 and 8 inclusive, meaning including the 6 and the 8. I want the probability that my X is in between 6 and 8, including the 6 and the 8. If I have my different possible outcomes, 5, 6, 7, 8, 9, all the way to all 15 users of Pinterest, I want the probability of 6, 7, or 8. My calculator only gives me the probability of that value and smaller, which means I will compute first the probability of up to 8 users, the probability of X is smaller than or equal to 8, and then I'm going to subtract whatever I don't need. I'm going to subtract the probability of up to 5 users, including the 5, so I'm going to be using the command CDF. The probability of X is less than or equal to 5. So it would be CDF 8 minus CDF 5. And again, Desmos allows you to put both together. CDF 8 minus 26.31%. 26.31% chance that the sampled people who use Pinterest is between 6 and 8. Thank you for watching this video. I hope you have a good day.